record. Yes, we are recording for those that can't make it. Good morning, good afternoon to everybody. Welcome to the Diesel Drivability Roundtable. Any first timers here? Just click on the chat. I know that I've sent a few emails, some of them have been forwarded on, but we get quite a few people when I look at the views on YouTube because I've been posting these now on YouTube for the simple reason that it's easier to get to when people have had issues with Zoom to get the recordings. So with that said, we have it there. So those of you watching the recording, you missed it. No, I'm kidding. You're watching it. So anyways, the roundtable for this month, it is April. What day is it today? The 23rd, right? Yep, April 23rd, 2024. Um, Still get a lot of phone calls regarding some issues. We'll talk a little bit about some things. If you have a topic you'd like to talk about, by all means, that's what the roundtable is for. Even though some guys are pretty much microphone or chat shy, but we're here to help you. We're here to talk about those issues you got or may have or topics you want to talk about. I'll have a few that I will talk about. As a matter of fact, I guess I'll go first. What do you say? Um, I'll go first. But again, everybody can hear me, right? So if you can hear me, you would have said something by now, I guess. So there you go. This Thursday, the 23rd, 24th, 25th, I'm going to be doing a webinar on networks. It's all free. But I thought I set the stage on it because I did talk about it on the last roundtable, is because I get a lot of phone calls about networks. So in this case, I wanted to show something I have shown before, but I want to show you what's going on for those of you that haven't really caught up on communication. Now, again, I'll go in more detail, but I wanted to do a quickie demonstration of this. Here's a Duramax 3-liter, the 1500. This is the 3-liter, okay? Now, what we're going to look at here is, again, the communication. So when we talk about communication, right, we actually are talking about pretty much, you know, connecting a scan tool, right? So you connect your scan tool, and as I'm showing you right here on my PowerPoint, I'm going to zoom in a little. Hopefully it'll show up on yours, but there's X84, excuse me. X84, that is your data link connector there, okay? In other words, our 16-pin connector we plug in. And we have seen the traditional terminals, but we have always said that 16 is battery power, so therefore we look over here and we see our battery power. Hopefully you can see my cursor there. And then we got 4 and 5, and 4 and 5, we scroll all the way down here, follow these black and white wires. You'll notice that is grounded G200. Okay, again, this is a 3-liter Duramax on a 1500 series Silverado Sierra. Now, this is where it all gets nasty here. Take a look here. We have said in the past that CAN communication is on 6 and 14. There's number 6 and there's number 14, right? You will notice that we have two. Does that look familiar? Anybody know what that is? Those are, they look like terminating resistors, don't they? But in this case, that's what we're seeing there. And in this case, those are 80 ohms. I thought they were 60 ohms. Oh, no, they're 80 ohms. So in this case, we have two 80 ohm resistors on between 6 and 14. And then we have a separate 3 and 11 with, again, 80 ohms of resistance, 160 total. And we also have 12 and 13 with, again, 80 ohms of resistance, total of 160 on each side. So who is this guy? Well, let me change the color of my marker here so I can make my point here, is that the guy that's in charge here is the serial gateway module there. So therefore, that's the serial gateway module. Again, I'm trying to get control here of my image. So as we talk about the serial gateway module here, you're going to notice once again, oh God, sorry, I'm having trouble getting on my controls here because it keeps disappearing on PowerPoint. There you go. So with that said, what I'm trying to say is that, as we go over here, again, bear with me. Let me go log. Jesus Christ. Come on. This is a very quick draw mouse. All right. Sorry. Let me go back. There we go. So therefore, you see the serial gateway module right there that's circled, and that is the module that is now connected to the DLC. So in the past, we used to see some type of module that we used to call the what? The gateway, right? The gateway is now the serial gateway module, but this is the headquarters for everything that's going to start to communicate. So I guess what I'm trying to say is If you haven't been good at networks, you need to get on board with networks because, like I said, I've been getting a lot of phone calls regarding communication issues. And Lee, I'm going to have you chime in and talk about your story we had last year about a sensor way in the back of the truck. But in this case, what I'm trying to say here is that you all your communication from the data link connector. In other words, when you're tapping in your scan tool, you're adding the scan tool as a module, if you will, that actually connects to the serial gateway module. So at that point, we're going to communicate to everything else. And that's where my next slide comes in. So as you look at the next slide here, you're going to see there's the serial gateway module there. So again, let me get my pin out. I'm going to try a different color because I have a hard time with fluorescent yellow. But in this case, there's the serial gateway module right there. Okay. So that serial gateway module goes south down here to the body control module, and then it takes a path north here. So therefore, it's going to go north this way. So therefore, we're going to see two networks. So we're going to split it in half right here. Okay. So therefore, this is one big network, and this is another network over here, all starting at the serial gateway module. While before, it used to be 6 and 14. So if I look at an early model L5P, we would have seen the same thing. Everybody follow me? So in this case, what I'm trying to say is that, yeah, we are actually seeing a big difference here. So again, we follow the serial gateway module down. We see the body control module. We see the power steering control module. Then we have a suspension module. And then finally, reductant control module where there's a terminating resistor there. Okay, so that's one side. Now on the other side, if we go this way, right, we see the brake system control module, transfer case control module, right, if equipped. And then we have our glow plug control module transmission. And finally, our engine control module, which houses our 120 ohm resistor there. So one of the things you'll be able to do is to measure the resistance. So this is where it also is different. You're going to have to get to the serial gateway module if you're going to do a physical check. And that physical check means that at this X2 connector right here, you're going to go ahead and tap into 14 and 15, terminal 14, 15 of the X2 connector on the serial gateway module. And how many ohms are we going to measure? Well, we're not going to measure 60. We're only measuring one side, which is this side right here. So therefore, what's the amount of resistance we see here? We have 120 ohms. So over on this side, let me erase here again. So therefore, on the other side, what do we have here? Well, on this side, we're going to have, again, we go this way. We follow this way and go all the way around, which is our terminating resistor, 120 ohms. So at connector X2 again, at terminal 4 and 5, we're going to measure 120 ohms to check the integrity to see if the flow is going there, which is something that hopefully a lot of you understand. So why are we talking about this is that what are you going to have if you have, again, communication issues? So if you understand CAN in the past, there was low speed, medium speed, and high speed, right? So the high speed has always been dedicated to 6 and 14. So as I go back again, there's that 6 and 14. So this splits up our various forms of communication here, whether being high priority or low priority. In other words, low, medium, and high. And that's what we're trying to talk about. So I guess what I'm trying to say is that, you're going to have to understand how these network works. Why am I getting to that? Because I've been been repeating this a little bit because again, it's starting to come over and over again. So there's my ECM up here. Okay. Hello, move out of the way. There's my ECM right there. So you'll notice this is showing now a separate, smaller network. Again, I call them local networks. So in this case, there's your knock sensor 1. There is knock sensor 2. And what do we have on these trucks? We have 3 knock sensors. So therefore, there's your knock sensor 3. So we're going to have what we call kind of a splice pack or connection right here at the bottom that interconnects all 3. You're going to notice there's a 120 ohm resistor within the particulate matter sensor. And then as we keep going northbound here, you're going to see the reductant control module here connected. So you'll notice, again, there's another separate network between, again, the start right here of the ECM, and then you're going to go over here to the reductant control module. Sorry, I left my cell phone on. I got to turn it off. So therefore, what I'm trying to show you there is that, again, you have the 2 separates there. Okay. So wait a minute. Yeah, we had an interconnection on the separate network, And now we have a local network between the ECM and the reductant control module right here, which is this whole side. So is it possible, which we have seen already, is it possible that we will get a complete shutdown of a local network? The answer is yes. So as I'm trying to say here is that can the ones that we've seen cause this on all manufacturers. I've seen it on Ford, I've seen it on GM, and I've also seen it on Ram, where we had a knock sensor. Most likely two, but sometimes it could be one, but most likely two is a common one I've seen. You guys can chime in on what you have found. But we have seen where knock sensor can actually ground the circuit. So you ground that circuit, you just shut off half of that communication. So we're learning here on the fact that I see a lot of people talking about and teaching about on YouTube about CAN communication. And the fact of the matter is, from a diagnostic standpoint, we have seen the issue be more on component versus wiring. Now, I understand if the vehicle's been in a flood, if it's been in an accident, a lot of damage to wiring, theft, whatever it might be, yeah, we can have a wiring issues. That to me is a little bit of the easy side because again, I can tap in to the circuit to measure continuity and see if I got those 120 ohms right we see right here. See that up there? Right there. So therefore, that's my 120 ohms. Here's another 120 ohms, and here's another 120 ohms, right? Now, please note, they don't make the 120 ohms just for diagnostic purpose, but also for stabilization and interference. But what I'm trying to say here is, you're going to have to know how to tap into circuit. Now, the codes do a decent job, especially if you got a U codes, of telling you what steps to take when diagnosing a communication or a network issue. But if you've been following other instructors and other channels out there, yeah, we have seen issues where it could be anywhere. And sometimes we try to isolate one circuit from the other. That's why we need to get accustomed. And in time, we're going to locate these 392s and these junctions 391s down here, which are these guys here, because this is going to be our form to test the circuits, right? Now, we can get to the connector, like, for example, on the reductant control module. We're going to locate terminal 31, 34, and we'll be able to do some ohms check. Now, you'll notice this is where electricity comes in. There's one path this way, there's another path this way, and we have two 120 ohm resistors right there, right? Fuel pump driver module and the ECM. So if I go down here to the reductant module, I'm looking at these two right here. So these two are in parallel. So therefore 120, 120, I'm going to read 60 ohms now here at the reductant control module. So if this doesn't make sense for you, another reason why you need to take electrical. So therefore, that's what my point is, because you're going to be a little off here on understanding it. Not to mention, if you're not savvy on electrical, you need to get the savvy on electrical, like I've said before. So therefore, this is all the same vehicle here. Again, so we look at the start of communication here. Then we look at the overall, and by the way, this is just powertrain we're looking at, okay? Powertrain. We haven't even hit the body controls and all that. That's another separate bunch of networks there. So in this case here, we can see a local powertrain network between the ECM, the reductant control module, and the related sensors, which again, I already outlined as sensor 1 knock sensors, sensor 2, sensor 3. So you'll notice that these three sensors on the knock side are actually all piggybacked together. Everybody notice that? They're all piggybacked together. So in this case, if there's an issue with one, we're going to cut communication to all three, which should make diagnostic easy because you're like, well, I know those three now on a 3-liter Duramax. I know those three are tied together. So if I got three sets of codes for U codes for knock sensor 1, 2, or 3, or any kind of code for them, that's really going to tell me, hey, I need to go check the network. So what I'm going to do once again is you're going to notice we have a parallel side right here. Oh no, this is going to get interesting here because you got 120 ohm up here at the ECM, right? You got 120 ohm here at the exhaust particulate matter sensor, right? So if you tap into the reductant control module at terminal 32 and 33, if you put your ohm meter, you're going to measure the resistance of this side, 120 ohms right here, 120 ohms right here. So what should it read? Well, they're both in parallel. So therefore, it's going to read 60 ohms. A quick check of checking the wiring. So obviously, if you get 0, you get an open circuit, you get, less than that, then definitely, you got a short there too as well. So again, all I'm just trying to demonstrate, and I'm going to get more in depth into it on Thursday about what you should be opening your eyes about, because it is very frustrating on what I've been seeing going on with electrical. So therefore we need to get a good grasp on that electrical more than ever. And guys, please don't have the attitude that I can't learn it. I'm not taking on a job. I can't tell you how many shops in the last, I don't know, 3 months that I've been getting information, or they seek diagnostic help and they just don't want to get on board with electricity. So you can learn it. You see what's going on with EV, and I already talked about that in previous, but just understand voltage is pressure, amperage is the current, the flow. And those of you, I do have an electrical online course I started on where, learn electricity. you know, what is the hardest thing for guys to understand is voltage drop, right? Y'all can grab a meter, you can all read 12 volts, right? But amperage and resistance and how they relate with one another, you start getting a little panicky. Let me give you an example. The heat is coming on, you know, air conditioning is starting to be used. We hit today, we're going to have like 95 degrees, 97 degrees here in Vegas, and air conditioning is going to come about. How many times have we seen conditions where we have talked about or we have seen multiple compressor failure? I mean, I got a shop that tells me, yeah, there comes that truck again, and guess what? It needs another compressor again. Every year we're putting a compressor on it. I'm like, dude, a compressor should go a long time. Granted, there's some aftermarket junk out there, but no. And one of the things I find out is that, you got a compressor front bearing or seizure of the pump, or starts to actually, you start having problems with the clutch. Well, the thing is, how many volts does that compressor need to work? All right. Should be like battery voltage, right? 12.6 or higher. Well, it's working. So the issue I got with technicians is that they get you mentioned the word voltage drop and they're like deer caught on headlights. They don't know what to do. Well, voltage drops mean, dude, this thing's supposed to work. The AC compressor clutch is supposed to work with battery voltage. What should you have? Battery voltage. So, gee, fire up the vehicle, turn on the AC clutch, and if the clutch is easily accessible on the top or the bottom, we got to get access to that connector, right? To the connector going to compressor. Yes, I know some are a nightmare, but some you can get creative and make leads to get to that connector. Don't tell me you can't. But at that point, I'm going to fire it up, and we're going to go ahead and put our meter across that compressor clutch. When that clutch engages, what should it read? Battery voltage. So if battery voltage is, let's say it's idling 13.8, what should you have there? 13.8. Congratulations. That's a voltage drop test. You're just testing to see, does this component have the voltage drop it's supposed to have? So that's important to understand. So if you haven't seen, let me switch now. If you haven't seen the video I have on my YouTube channel, right, you're going to notice that I'm talking about here, and let me make sure the sound is, yeah, it's muted. Hopefully it does. I've already tested this. Hopefully you'll be able to see it. But what I'm talking about in this video is doing a voltage drop test. Now, for those who don't know what I'm looking at here, what I have is a marker light. This is a popular exercise I do on the training boards that we do on our electrical training. All it is a marker light and a tail light, and we connected them in series. Okay, we just connected them in series, one after the other. So there's my switch and my fuse, and then over here is my bulb, and then there's my second bulb, right? Big deal, right? So what I do is I turn it on, I quiz the guys. Some of you that have been in my electrical training, probably have seen this, but we find out that the marker light's the only one that lights up. So therefore, if I open the circuit, right, you can't get in, you'll find out that the marker light is working, but the tail light doesn't work. So what I do is a voltage drop test. You're going to test voltage to it, right? So all you're going to do is, like I said already, I'm going to measure voltage across I think I do the tail light first and then the marker light. But again, I'm turning on the light right there. Excuse my shoulder there. But I'm going across the tail light. The tail light does not turn on right there, right? So, but we could see that the voltage drop is how much, right? 0.209. Okay. So it's like, well, yeah, this bulb's not turning on. It's only got 0.2 of a volt. But you notice that I did it with the circuit on. So anytime you do voltage drop testing, you do it with the circuit on. Okay. Believe it or not, I've been to community college where I saw an instructor teaching a class, and he was insisting that you do a voltage drop test with a circuit off. No, you do it with the circuit on. Okay. That's what I'm doing, right? How are we going to test the AC clutch? We're going to check it with it on, right? All right. Now, here's the moral of the story. We see that there's 0.209. So I continue playing the video. Again, you can watch the video in its entirety. It's not that long. It's only like 6 minutes long. But in this case, you're going to see that, again, I got 0.208. Now I'm going to check the voltage across. I got to quit moving here so you can see this. Across now the marker light, the guy that's lit. Hopefully you can see it on the lower end that the marker light is lit, right? So what I do simply is I just go ahead and, right, do a little notice that that marker light has 13.64 volts. So he's hogging up all the voltage, okay? So the reason why my tail light does not turn on is because the marker light is hogging up all the voltage. Well, he's on, he's working with 13.64 volts, right? The source in this board is 14.2, I believe it is, okay? Now, here's where it's gonna get interesting. What I'm going to do here is I'm gonna go ahead and disconnect the two leads going to the light that's not on, which is the big fat tail light, right? I'm going to take it off. And what I'm going to show you there is I'm going to look at what is the voltage with it connected versus disconnected, right? So there you can see me take the lead off, right? Take one lead off, take the other lead off. And I'm just going to measure, again, the circuit with, again, the connector off or the leads off the bulb. In other words, like when you take a connector off and you're going to go ahead and measure it that way, look at the open circuit voltage, what we call open circuit voltage. What am I showing now? Okay. So therefore, I got full source right there. Everybody see that? So in this case, we have full source right there. So in this case, that tells you that when you disconnect circuits, you're going to read just the pressure available there, right? Now, I believe I reconnect them right there just to show you what happens when you reconnect it. What happened there? So the moral of the story is hopefully y'all catching on. If you're catching on, let me know because this is important to understand. So therefore, what I'm trying to say is that, when do you check a circuit? You check it when it's what? On. And that's why we tell you to back probe. So therefore, you're going to back probe on a connector and see the source voltage. So let's say I got a map sensor in my hand, and I could look at this map sensor. I know there's 3 wires going to a map sensor, MAP, right? And that map sensor has 5-volt reference and a signal return, which is ground, right? Or low reference, excuse me. Sorry, one more time. 5-volt reference, signal return, and your low reference. Your low reference and your 5-volt reference is your power and ground, if you will. 5 volts. So therefore, I can do a voltage drop test across it and just go and probe behind the connector because now you're testing it when it's at work, when it's doing its job. So that's what we call dynamic versus static testing versus you want to test the circuit life. So again, when do you want to test circuits? Like I used the AC compressor in example, is you want to test it again when it's actually running and on, okay? Now, if you missed this video, it's on my YouTube channel. It's free of charge. You can watch it there on the YouTube channel. Now, let's get one thing clear. Because when you actually test computers or modules for power and ground, right, you need to always do a voltage drop test across it. But how are you going to do it? With it on, key on. So therefore, key is on, and you're going to back probe on the connector. So we saw the NOx sensor, for example. And if a NOx sensor uses power and ground, because generally a NOx sensor has power and ground and 2 or 4 wires for CAN communication, like you saw in the wiring diagram. So in this case, what I'm trying to say is you're going to check to see that it has power and ground, but you're going to do it with it what? On and connected. Because here we just showed you how they can actually vary. Okay, so very important to understand. So again, obviously I'm not going to go into, this is not an electrical class, but what I'm trying to say is, we're trying to show you that, we need to understand that you're just measuring pressure when you're testing voltages on open circuits. Lee, are you still out there? Do me a favor, buddy. You did have that issue, what is it, last year or the year before on that CAN network? Remember that one? Lee,
It was on that NOx sensor, number 2.
Yeah, can you just quickly tell us what that one was about?
What? Well, it'd been at multiple dealers, Tony, and every time, I don't know why they didn't look at history, but they'd replace the NOx module and it would work for a while and then it would fail again. And what would happen is disturbing the connector to that NOx module, you would disturb it enough to where you'd get connection again. and it'd be fine until it rattled around and lost connection. But come to find out, what it was is there's 3 connectors between that Knox module and the ECM. And we found the biggest issue was the second connector heading towards up by the front, be the right front kick panel. You open up that connector and there was barnacles growing inside that connector.
Yes. Yeah. Because I'm disagreeing. The reason why I bring this up with Lee, guys, is because I'm disagreeing with a lot of guys out there regarding network issues. I'm finding a lot of the network communication issues caused by bad connections at a module or sensor, as you can see here.
Yep. Yep.
And but not in the wiring as much as people preach it is, because they're teaching theory. They're not teaching real application. Yes, you're going to have circuit wiring problems. I get it, but not as chronic as they say it is. So therefore, corrosion is going to be our best enemy. But where does it occur at? It's going to occur at a connector. I mean, do you agree there, Lee?
Yes, sir. Yes, sir.
So
And I keep running into that every now and then, and I'm almost to the point where, all right, let's pop all the connectors and start checking continuity between the ECM and the Knox sensor before we even start. And you'll be amazed opening up those connectors with the salt and everything else that they put on the roads, Tony, what you'll find.
yeah, because it's all underneath. Those knock sensors are exposed to all the elements.
Yep.
Not to mention, as they drive through 4 feet of water, they don't understand that truck's not a boat. So yeah, it does happen. So there we go. All right, very good. Any questions there? Please turn on your microphone if you have any questions. I think we had a guy that wanted to talk about Matthew. Thank you for your comment. Yeah, check circuits that are loaded on. Yeah, Matthew learned that because we did that. We took the electrical boards to his shop. So he knows all about that, about testing circuits. So again, why did I talk about the voltage and voltage drop? Is because these modules that you see right here, again, have, which is not shown because this is just a network wiring diagram. If we pulled out the full diagram for the Knox sensors and all the modules, you need to understand that you can have high voltage drops like Lee just verified, where you can have barnacles growing there.
Yep.
So I guess corrosion. So yeah, connectors could be a problem there too. But again, it will cause a high voltage drop. So it will not have the source voltage it's supposed to have to it. So the good news is all these modules you see on these wiring diagrams all work with battery power. So, like I said, that grunts. And, I've been working on my diesel master course online, and I've been bringing up some old scenarios and some old videos that I found that we did. And it's like, it's a never ending story about measuring source voltage and power. I got a guy that has a problem with the Duramax, and I said, we're down to the ECM with a P0606 code. And I'm like, dude, before we condemn the ECM, it does look like it is the ECM, but before we condemn it, we better make sure we got source power. And the thing is, what's he doing? He's disconnecting the connector, right? And he's probing with the connector on an open circuit. I'm like, that's not a dynamic test. You're doing it wrong. So when I say the word voltage drop, it's like it's gone, right? So guys, come on, get on the electrical bandwagon. So therefore, we're trying to help you out with that. So, I mean, y'all agree? I mean, I'm looking for comments here. Hopefully,
Tony,
you feel the need. Yes, sir. Who's that there?
it's Matthew here
Hey,
calling
Matthew.
in. Just wanted to kind of kind of go along with what Lee just said. We just had a 19 model 6.7 Ford here that it was not a Knox issue, but our customer was a garage that had been working on this truck and wasn't sure what to do with it. The water and fuel light was they couldn't get it to go out, and up under the truck was muddy. In fact, the previous shop thought possibly this truck had been submerged or in the mud or some way anyway. And with that new enough, it was actually derating the truck because of the water and fuel light. It thought it was on. They had taken and had replaced the primary filter and the whole filter shell because it was sucking some air and whatnot. Unplugged the water and fuel connector, so there was no connection going to the PCM. Still the same thing. Anyway, one of our techs here eventually went and found a splice in the wiring diagram and found moisture in it. Dried the moisture out, plugged it back together, and water and fuel lights out, and the truck's running fine. Kind of similar thing that you all just talking about. So just kind of reiterating what you're saying is true in different application.
Yep. because it's a huge gamble if you're not doing the proper voltage measurements. Because like I just got a text. I just looked at my text right now. I just got it's been going off like crazy, and I got a bunch of U codes. I'm like, I should have texted him. I said, get on the roundtable right now. All right, very good, Matthew. Thank you for saying that. Very important to understand. All righty. We have Mr. Let's see, who's else on the chat. I saw
I'm
Mr.
here, Tony.
Jesse. Jesse, you there?
Yes, sir.
All right, Jesse, what's going on?
I got a 99.73 that has been kicking my butt for better part of a month now. Came in, I talked to the customer about it again yesterday. He was driving from New Mexico to Nevada, and while driving, he wasn't stopped or anything. He just lost all power. And I say power, I mean loaded power, as in the ability to build boost. So he brought it to me, no power, no boost. I looked at it initially, and it wasn't building pressure from the high pressure oil pump. It would only build up about 2100 psi. So we put a high pressure oil pump in it, and then the same result happened. While I did the high pressure oil pump, I did the IPR because the old one was crusty and bad anyways. So we got the same result. So from there, we put injectors in it, and all this came from Ford, all OEM. We did injectors, same result. Did an ICP sensor, same result. I took a known good IDM out of my personal truck, put it in it, and that did not fix anything. I shipped the PCM out to Diesel Technology of Chattanooga. They said the PCM tested good. I don't know how reputable that is because it's got a barometric pressure sensor code, and I cannot find a external barometric pressure sensor. We did a camshaft position sensor. Tested fuel pressure everywhere that can be tested, all the way to the cylinder heads. Tested low end oil pressure, and everything to this point has tested normal. It just will not build boost.
You tell them about the IPR duty cycle too, by the way.
So when you're sitting and idling after the vehicle's warm, I get an IPR percentage about between 7 and 9%. Now when I go to take off and I've wide open throttle under acceleration, given this is a manual, so I have to anticipate shifting, I never get any more than 28, 29% out of the IPR. And wide open throttle on PSI for the ICP never sees any more than 2200 PSI.
All right, guys, you heard. Anybody got any ideas? Because I have been in communication with him on and off the last 2 weeks, and I'm almost tapped out. I got to get to the truck if that's the next step, because he lives quite a bit away from me here. So, anybody got ideas? Again, no boost, and he can't get over, what is it, 2000 again of ICP pressure?
Yeah, roughly, yeah.
Yeah, you can
And if
see it when he
I
accelerates.
even if I'm sitting and idling and I try to wide open throttle in neutral, it'll slowly build up, and I say it'll go from idle to 1500, and then it'll struggle building up to that 2500 RPM mark.
Matthew chiming in here, Jesse. I got some questions for you.
Yes, sir.
Have you mentioned about this barometric pressure thing? Because I actually, interestingly, you just said about this. I didn't have the exact scenario, but a very similar with a 2001 manual transmission, 7.3, that was a local truck here that was recently in a accident. And the customer told me that it basically what had happened, he had a fifth wheel trailer behind him, and it was on a slick road, and the trailer wrapped around and come over and bumped into his side of his truck. And ever after that, he just did not have power. I didn't do a lot of diagnosis with him, but being that he said it clearly happened then, I had another powertrain control module here that I swapped out. And I drove the truck before and I drove it after. and a clear difference the way that truck performed. Now, it wasn't completely dead, no power, but it was significantly dead as soon as I went and popped in my other used PCM, difference of day and night. And I have that PCM off being repaired right now. But I guess one of the questions I've got for you is, what is barometric pressure actually reading since you have this fault code?
Barometric pressure out here is reading 13.6.
And is
So
that
it's
what you would
actually,
typically
yeah, it's
see
actually
there?
reading. Yeah, it's actually reading correctly, even though it's got a code for it. Low input code, I believe, is what it is.
Now, mind you, Matthew, he sent that computer out already for inspection.
Yeah, I heard him say that too, but he still has that fault as well.
Yeah, it's a hard fault. It comes right back.
So
If-
yeah, it's hard to come by a manual
Yeah.
transmission computer.
Well, I'll tell you, I have one. The only problem is it's in this guy's truck right now. If I can get it out, I'd be more than happy to loan it to Jesse and let him try it.
Well, it's
Once
something
I
we
get-
can look at.
Once I get this other good customer's ECM back, I can do that.
Yeah. But
Yeah,
it'd be
that'd be
interesting what
awesome.
they repair on it too. So
Right.
but yeah, he is getting, because that's where I told him, because we did talk about this. And I said, we got to the point, because we did a lot of different things that I told him to do that he did. And the thing is, I go, ECM, that's why he sent out the ECM.
Correct.
And in this case, but he gets that barrel code, and you could see that the commanded, is not getting. In other words, it's not letting it go over, because in order to make boost, you need heat and you need fueling.
Right.
So therefore, he can clearly see he's not going over 2,000 of ICP pressure. And the duty cycle seems to be showing that too. So if I'm not mistaken, if I remember.
Yeah,
So,
the exhaust manifolds are not getting hot either. I sprayed engine spray paint on them and just stood on it going down the road, and it did not do anything. The spray paint color was still there.
One other question for you, Jesse. Imagine Tony and you have already talked about this, but have you tried to fool the turbo or the map sensor and make it see air pressure? Just hook up a regulated shop air and verify that it actually can see pressure in any way.
Yeah, I used my vacuum pressure tester, and I can make it recognize 42 minus barometric pressure. So it's about 20, what is that, 26 PSI. I can make it see that.
Gotcha.
Yeah, it's just not getting it. The engine is just not producing that pressure, or the turbo is not producing that pressure.
Gotcha.
now he's got a whole new set of injectors in there too. He checked the inlet line of the fuel on each side where it goes into the head, each fuel line, make sure that that line is not plugged or restricted. We did a total output test, because if he actually closes the IPR manually, he goes over right over 3,000, right, Jesse?
Yeah, it goes right to
Yeah,
3,000. Yeah.
So that tells me that the high pressure system there's no leaks, there's no issue there. So
Hey
that's
guys,
why. Go ahead.
do you suppose maybe the accelerator pedal position sensor ain't sending the command all the way, or you get a code for that, wouldn't you, if you had a bad?
You
I
should
would
get a
imagine
code.
you'd probably get a code, but like I said, in neutral, I can wide open throttle it, and it'll go there. It'll get there to that 3,000, 3,500 RPMs, but it struggles and it takes a minute to get there. And when it gets there, it starts popping out of the exhaust. So I don't think the
And at the
accelerator
same
pedal
time,
would.
yeah, and at the same
Yeah.
time, again, like I said, he's not getting over 2,000 ICP pressure.
Correct.
So, he's done the cam sensor, and you got a new set of injectors in there, like I said already. So, I'm pretty much tapped out on what it is, but given the fact that he's got that barrel sensor code setting is kind of still makes me wonder if they really checked that damn sensor when he sent it out for inspection. So,
Yeah, and
Anybody?
the date of manufacture on this truck, the tag has been removed, so I can't tell what the date of manufacture is to verify if it even has an external or an internal baro sensor. But I cannot find an external one anywhere under the steering column.
Yeah. Anybody got any other ideas? Nope. Well, Matthew, how long do you think you'll have that computer for? So before
I'm
you get it
gonna
repaired?
check. I'm gonna check on that there to wear it while it's coming, and I will be back in touch with you, Tony. That you can get in touch with Jesse, or if you want Jesse to contact me, I'm more
Yeah,
than
I'll have him
happy to.
contact you.
Yeah, more than happy to try to help.
Yeah, I'll text him your number to help. Yeah, if you can lend that computer, that'd be great. You know,
Yeah,
Yeah.
I'd appreciate it
Jesse,
a lot.
because we pretty much have covered everything. He even
Everything
he
that I
even
can think of.
swapped the relays for the IDM and PCM, make sure we don't got a power problem.
Yep.
Everything seems to be on the up and up. So, all right. Well, Jesse, tell you what, I'll get you in connection with Matthew, and if Matthew's kind enough to lend you a computer, you're going to owe him big.
Yeah.
So, because it's hard to find a manual transmission. I know, I've been there. So, definitely do that. So,
Cool.
all right. Like I said, I'll get you in contact with him. I'll send you a text with his phone number. Matthew, you're cool with that, so that's great. All righty. Any other questions here? What else we got going on? And by the way, Jesse, you still on? Oh, did you leave
Yes,
us?
sir.
Oh. What other issues you're hitting out there in Pahrump? What other issues you guys having on trucks? What's the common issue you guys are going on?
Uh, well, nothing out of the ordinary. We've got mainly cylinder head issues on 6.0s, which everybody likes those. I've got a couple of computer issues, one on a I think this one's an 04 Ram 3500. And oh, this one over here. Okay. So I've got an 07 67 2500 Ram. I get a constant issue. It's intermittent though with the throttle light, the throttle indicator. It's gone to the dealer. I've put an ECM in it. We just put an instrument cluster in it. We've tested the wiring harness. We replaced the pedal position sensor, and this code is still intermittent. The dealership has replaced the big bulkhead connector that's right underneath the hood, next to the master cylinder. Well, they didn't replace it; they repaired it. But I still get this intermittent loss of pedal, and that lightning bolt comes on.
You have an APP code on that?
Yeah. Yep. APP2.
Okay. This one. Yeah, actually I had an article from Rob Kennedy on that. About that there was a connector underneath the battery tray. I got to look it up, but I just did it on my advanced drivability thing. But I believe you got a connector there. So I'm the kind of guy, I'll be honest with you. Does it acknowledge which circuit it is, APP1 or APP2?
Yeah, it says APP2.
Yeah. So the habit I have is I'm the kind of guy that doesn't even try to find an open or an intermittent. I just bypass. I go from the sensor all the way up to the ECM on the APP2. Yeah, you probably got a connector problem. Let me locate that one. It's in my files. Actually, like I said, I gave it in my drivability class I just did about a few weeks ago. I'll
Yeah.
cover that with you. But yeah, definitely monitor the APP signal when you get the issue intermittently. But I'm almost positive you got intermittent open at that connector that they have a problem. I believe it's underneath the battery tray, but I got to look at it again. So
Okay.
anytime you got that kind of situation, point A, point B, I don't mess around with them. I just run straight wires going to it, so to get it to actually see if it still does it at that point. So, but
Right.
usually I
Yeah.
fix them immediately. So that's what I'd be doing. But I'll get you that information on that too. All right, cool. A lot of 6.7s, power strokes.
Yeah, we do see quite a bit more of them now. Um, there's no Ford dealership here in town, so we see a lot of Fords. We see some Dodges, and rarely we see Chevys because there's a Chevy and a Dodge dealership. Their incompetence level is debatable.
That's a story everywhere.
Yeah,
I get it. They can't hold on to good technicians. They let them go.
yeah.
I get it.
But
All
we
right.
stay pretty busy, that's for sure.
All right, cool. All right. All right. Thank you, Jesse, for your input. I'll get you that info on that APP though. What year's that truck, by the way?
This is a 07 and a half, 08.
Yeah.
First generation of the 6.7.
Okay. I'll try to look that up for you.
Thank you.
All right. Very good. Thank you. Thank you. Any other things to chat about? Any guys having any other issues there? And come on, this isn't a roundtable here. We're looking for any issues going on. Clint, you got anything else going on? Clint, you still there? You can unmute your microphone, Clint. Clint always has something going on. And we also have, let's see who else is on here. You're welcome to add anything. Anybody else there?
Tony, it's Matthew again. Don't want to
Yep.
dominate the conversation, but I got some
Yep.
things for
Nope.
people to talk about. Number one, been running into some trucks, both Duramax and 6.7 Ford, where we're having trouble with the injector hold down bolts snapping in the valve covers and from corrosion and whatnot. We do have the ProMax tool to drill the bolt out of the head on the 6.7 Ford, but nothing other than trying to drill the bolts out of the aluminum covers or break the covers apart. Just curious what people, other shops are doing to try to deal with that. And then I'll share what we did with the last 6.7. We just ran into that, and we had a Duramax LLY here that we ran into the same problem with very recently, and ended up having to pull the cylinder head. So I'd like to have some discussion on that. Then I do have another comment for some things we're seeing here in terms of just info on L5P too. So question on, anybody got any more insight on how they're handling those? We've tried welding nuts on some of these broken fasteners. It's just too corroded down in there. So yeah, I'd like to hear any discussion on that.
I got something for you, sir. This is
Go ahead.
Jesse again. So I got penetrant from Kimball Midwest, and this penetrant is by far the best penetrant I've ever used. I would highly recommend you get some. When we get something that's stuck like that, back it off a little bit and try to get as much as we can down in that hole, and just let it sit there for a couple hours, and then run it back in, run it back out, spray a little bit more. And ever since we started using this penetrant, we haven't had a broken one since.
In other words, before it snaps. Yes.
So are you able to move the bolt though? First of all, or are you letting it soak there, Jesse, before you even trying? Obviously.
Yeah, we can move it a little bit at first.
Okay. Because these here are at least these here were the point where you weren't moving them at all. It was that bad. In fact, what we ended up doing on the one here in the 6.7, after having a little bit of a disaster with the LLY, we literally had tried drilling it and we're having some trouble. So we ended up and this is not what I'd like to do, but we ended up taking a hole saw down around the broken fastener to get the cover away, and then we're able to it was just corroded all the way down through that cover part and all the way down into the head. Certainly don't like that because all the material going down in the engine, it's not a good, but maybe you have to inform me which penetrant from Kimball, because they do stop here too.
Let me I'll walk over and I'll read the label, tell you what it is.
Matt, is that, this is late, Matt, is that corroded like the 7.3 glow plugs after 300,000 miles? Same kind of deal?
I would say this is more like I don't know how much you've had with the Duramaxes at all there, Lee, but when the glow plugs, how they can get kind of oxidized and
Right.
it's that kind of stuff there, I would say more so.
Okay, all right.
Did you say you had the Promax tool for the Ford? How do you like that?
We like it. Certainly any of the Promax tools, we've bought a number of them. In fact, once we got the head or got the valve cover off on this truck, when the bolt was still broke off down in the head yet, because when I went to twist the piece of aluminum valve cover and the bolt, it was still seized in the head yet. So we have the tool that goes down in there and drills that out perfectly center, and it works beautiful. It does. Also on the same truck, the number that was on number 7 cylinder, number 3 cylinder, it had broken. I guess both of them had broken injector hold down clamps. There's a bulletin from Ford about those hold down clamps. But the number 3 injector must have been backing off and let the carbon come up past the injector. And we had more recently bought Promax's tool to extract the stuck injectors in the head. That has a fork, and then on the fork they've got a screw to kind of force it up, a pretty heavy duty screw. But then on top of that, they even have a place to put a air hammer with a pin. Basically, you put in the end of a tip in the end of your air hammer, and basically air hammer it up. And tech used that, and it really helped in getting it out. It was really in there tight. They even now have another tool, a reverse air hammer, that we did look at. We didn't actually use on this application. And that is also, it's a whole different kit to help extract these frozen in their injectors. But this particular truck was tight injectors and seized injector hold down bolt. And we even were able to weld a nut on the bolt that was seized, and it broke the bolt off going down even farther. So yeah.
Matt, this penetrant by Kimball Midwest is Torque Charlie Bravo, Torque CB, non-chlorinated. It's in a red and white can.
Okay, thanks.
So
All
that
right.
Promax tool then is for getting it out of the head, not the valve cover. Is that correct then?
So yes, the Promax tool that we have is the one that once the valve cover is off, the bolt's broken off in the head.
Yep.
So you can precisely drill that bolt out and not end up wallering it out or having to put an insert in, unless you happen to get really crazy with it. You can literally tap right down through the same and have the same threads. It'll clean them right out, and it's that precise. That's the value of that tool from them. And then I was talking about also that we have a separate tool for the injector puller. That's a different tool from Promax.
Okay. Yeah, I just got that puller tool, but I haven't used it. But I've used some of their other stuff, and it's been good.
Yeah, it has been very good for the most part.
Yeah, alignment is everything, so that's what you're paying for, definitely. Okay, very good, gentlemen. Very good. Thank you for that input, Mr. Matthew. Hopefully, then Jesse, thanks for letting them know about that. So
Yes.
it's it's a never-ending story there. So, by the way, are we using any kind of NICs when we're reinstalling?
Yes.
Yeah, I figured so. So definitely got to use some kind of NICs there. So definitely want to do that. Very good. Okay.
And Tony, I'll say this yet too. I was going to mention about L5P. We have now got the second truck here. It's a 19 that we are replacing turbo on because of VGT actuation pin is worn in the housing of the exhaust housing. Both trucks, just did some checking, are right shy of 200,000 miles. One was a 17, one's a 19. So don't know if that's going to start being a regular. And maybe Lee knows on the 6.7 Fords and these 2020s and up. I'm just kind of wondering if that's going to be an ongoing problem with the cycling of the VGT with the Borg turbos.
Well, they're doing the cycling to reduce the stickiness and the carbon formation that's inherent in them. So, Lee, have you heard anything about that?
No noise yet, Tony.
No.
And I usually won't get a lot of info on it, Tony, because they do it under warranty. And they
Mhm.
won't give me access to warranty stats on turbos on specific vehicles.
Okay.
But I'm going to ask now that Matt brought that up.
Okay.
I can get it from another source.
Very good. Okay, Matthew. How many miles on these L5Ps, by the way?
Like I said, they're both right around 200,000 or just shy
Oh,
of it.
okay.
And I've
So
looked at the hours on them. It's not like they're high hour trucks. They're right. The hours are pretty close to or even below what the mileage is on the trucks. So um, the one truck I think I told you previously about, Tony, well, we had an actuator or a code that generated, and we thought maybe it was an actuator, only to find it was very lightly sticking. This 19 that we got in the shop here now, the customer had done some other work to it and brought it to us, and it had a PO 003A code and maybe a few other communication faults. And we said, hey, we're definitely looking at this area because of what we saw the last time. And sure enough, you could see soot kind of coming out of that pin area as on the last truck. So that's an inspection point right off, is look for soot coming out of that little pin area. And once we got the turbo, and we've got the turbo off, and once you could kind of see it by cycling the VGT on the truck by hand because you got the external linkage. But we pulled the linkage loose, and what we saw once you took the linkage loose is that as you move the lever back and forth, you could kind of see a walking or a shifting of that pin going through in the bushing area. There was just excessive slop. So it looks like it's going to be an issue, or it could be, unless
Yeah.
these are just early build turbos that are doing this. But
yeah. Okay. Very good. Very good. Very good. All righty. Any other comments? It's approaching the hour mark. So all right. Thank you, Matthew. Any other things, Matthew? We're good? We're good, we're good, we're good.
yeah, I think so, Tony.
Okay, appreciate your input and all your support there, my friend. Just to remind you once again, look for we're doing the Lucas webinar on Thursday. Look for that. You should have gotten the email. Again, if you don't know my email, I'll type it in right now for those of you that don't have it. It's tsalis@dieseltg. As Matthew is going along, and he's actually using now we just got his crew for the Diesel Master course online. So again, hopefully Matthew likes it in terms of watching small videos. Because a problem that I'm having with a lot of shops is keeping the guys up to date. Like I was at a shop not too long ago, and let me tell you, those guys, you talk to them about just basic overview of how these trucks are laid out from a 6.7 Power Stroke to a 6.7 Cummins. It's a sin. So we now have the Diesel Master course online. So some of you have taken the Diesel Master course here in Vegas. Everything that's in that course is now online, so it's learn as you go pace, but it's not just videos only. It's quizzing you. So therefore you can work at your own pace and watch small clips of videos at a given time. So it's not taking place of the on-demand videos. There are some people that just want to watch something about a product that's there, but please note that we have the DMC. So I'm giving a free trial. If you want to look at it, just email me. It's in the chat, and I will send you a link so you can try it out for free. And then if you do like it, then I'm gonna want $1,000 for it. No, I'm kidding. I'm charging way under that. So therefore, there you go. Guys, I wish there was more training out there when I was coming up through the ranks, and that's what we're trying to provide for you. So the excuse that people are saying, because next week we're doing a Denver class, a live class on Power Stroke 6.7. I'll be in Denver next week. And we had to cancel the L5P because a lot of guys are saying, I love to go, Tony, but I can't make it because they're so busy, blah, blah, blah. All right. And then I got it online. So don't think that I'm trying to help you out because they're saying, is there any way of watching it online? It's online. So there you go. So if you're interested in that, let me know. Again, we're just trying to help you out. So anyways, with that, any last minute comments?
Yeah, Tony Clinton here. Is the AC course you created last summer, is that for can I purchase to watch that?
Yeah, it's on the on-demand right there. So there, yeah,
Oh,
we got
okay.
it. Yeah, we got it's on the on-demand courses. It's in there. So if you go to the on-demand course on the website, click on it, and yeah, that'll get you access to all the AC stuff. And obviously, after you're done watching it, you need to give me a call because I want to review a few. I go live and review a few things with you.
Okay.
So don't say that I'm trying to support you there. So yeah, we got the AC, and that's the one thing I was going to say as the end here. I'm glad you brought that up. Is we got the how many guys can't read the AC gauges and what they mean? So definitely it's AC season coming up. So therefore we have to understand what we're looking at, what it reads and how it all reads, and proper procedures should follow. So yeah, we do have that on-demand course online. I'm glad you mentioned that, Clint. So guys, get on the AC bandwagon. If you're not AC savvy, we can get AC savvy and get these AC systems working right. And just to tell you, one last thing here on AC is the AC on my trucks, my 06, I still got the original compressor. I still got the whole system still working the same. In other words, kind of tells you how long an AC system should work if you do the job right. So
Must have been built on a Wednesday.
ha ha. There you go. So in this case, yeah, you should know what you're doing with AC. So guys, there's a right way and a wrong way. All right, very good. Any other comments or questions? All right. With that, I'm done, guys. And Jesse, I'll be sending you here Matt's information, and you guys can be in contact about the computer. Then we'll go from there, my friend.
Thank you, sir.
And with that, any other